Good evening, my YouTube viewers. It is Crystal here. I'm just here because I wanted to do another code review for you. And basically, I'm doing one of Kaggle's community competitions. And basically, it's to do with telecom churns. And I will say that I tried 3 different models. I tried the passive-aggressive classifier. It didn't do very well. I tried a perceptron. It did better. And then I tried MLPC, that's multi-layer perceptron classifier, and it scored 93.886% accuracy. So I decided that I would go ahead and do a code review on this. And so I've been studying TensorFlow, but I just wanted to take a break from TensorFlow to try out sklearn's neural network and see how sklearn's neural network works. But I could also, if I have the time, I also can try the model on TensorFlow. I mean, I could do that tomorrow, try that out on TensorFlow, and see if the accuracy I get with TensorFlow is better than the accuracy I get with sklearn. But the thing is that I'm using sklearn's only neural network multi-layer perceptron classifier. I think that's what it's called. It's called MLPC. MLP classifier, multi-layer perceptron classifier, so I was right about that. And so what we'll do is we'll do a code review, and this was a competition, and it had a lot of rows and a lot of columns in it. And so because it had a lot of rows and a lot of columns, I had to do a lot of manipulation of the data. And so that's generally what a real data scientist would do. A real data scientist would, one, spend a lot of time cleaning the data, and then the data scientist would go speak to the users and find out information about the data before they could make their decision. But I don't know that much about telecoms, so I did my best, scored a 93.886% accuracy, and like maybe tomorrow when I try it on TensorFlow, maybe I'll score better, who knows. So the first thing we did was we created the library, and when we created the library, we created the program. We created the program on Kaggle's Jupyter notebook, and the Jupyter notebook is stored in my account. But what I will do is I will give you a link to the Jupyter notebook in the description box of this video. And then you've got your problem statement. Problem statement is predict which telecom customers are likely to churn. So if it's 0, they're not going to churn, and if it's a 1, they will churn. And then so after we've read our problem statement, we import our libraries. So we're going to import NumPy as NP, which creates NumPy arrays, and it performs numerical computations. We're going to import pandas as PD, which creates data frames and series, and it also processes the data. We're going to import OS, which goes into the operating system. We're going to import sklearn, which provides machine learning functionality. And then we're going to import matplotlib.pyplot_splt, which visualizes the data, and we're going to import seaborn as SNS, which visualizes the data statistically. Then we're going to use OS to go in and retrieve the files. So you've got something called data dictionary, and the data dictionary just tells you what all the acronyms mean. You've got your sample submission, you've got your train, and then you've got your test. And then you're going to use pandas to read the files and convert them to a data frames of train, test, submission, and data dict. So now what you want to do is you want to see the train file, and we set it up so that you can see all of the columns. So pd.set option, display max columns, none. That sets it up so you can see all of the columns. And it's got 172 columns, so it's got a lot of columns. And it also has an ID. Oh, I'm sure I can delete the ID. That may improve my score if I delete my ID, because I forgot to do that. So that's one thing I can do, is delete the ID. So we're going to check train info. It didn't give me that much information. It says 135 floats, 28 int 64s, and 9 objects. So we can see one thing that I forgot to do was to take out the ID. So that's one thing I could possibly do to improve my score. And then we look at tests. It's got 171 columns, same information. We check for train. We've got 1,835,086 null values. And we check tests. We've got 788,051 null values. And then we check. We created our submission, which submission says what Kaggle wants to see when you submit it. And then you have your data deck, and what the data deck tells you what everything stands for. So we're going to analyze the train. We're going to create the target. The target is train.pop churn probability. And then we use Seaborn to plot the target, and you can see we've got a lot of zeros and a few ones. So, and then we do a value count so you can see how many zeros and how many ones you've got. We're going to combine the train and test. So comb equals pd.concat train test. And you can see comb now. So you've got 99,999 rows by 171 columns. We're going to drop any columns that have only one unique value. So if it has one unique value, we're going to drop it. We're going to drop any object columns, any columns that are an object, we're just going to drop it. Because I don't know what the object columns mean anyway, so we're just going to drop it. So that takes us down to 152 columns from 171. So that takes us down 19 columns. Okay. So yeah, so anything that had, so we combined our train and our test, which we already talked about that. Comb equals pd.concat train test. So we've got 171 columns. We drop any columns that have only one unique value. And the reason why we do that, because it doesn't add any meaning to the prediction. So that took it down to 158. So that would be about 13 columns that have only one unique value. We're going to drop any object columns from the data frame. Any columns that were object, that's going to be dropped, because I don't even know what the objects are, so I'm just dropping them. So now that's 152 columns, so that dropped 6 columns. Now what we're going to do is we're going to remove any columns that have a high correlation. So any columns that have a high correlation of greater than 95 percentile, those get removed. So now we've got 146. So I think that dropped it 6 more columns of data. Now we're going to impute any missing values, and there are a lot of missing values. So if the column was a float, it was going to get the mean, and if the column was an integer, it was going to get the median. So we've imputed all the missing values now. We don't have any more missing values. And now we're going to normalize comp B, and what that does is that takes all of the values and converts them to a value between 0 and 1. Now what we're going to do is we're going to define our x and our y variables, which is our independent and our dependent variables respectively. So y equals target, x equals com B, 0 rows to the length of target, and x test equals com B. X equals com B, 0 rows to the length of train, and x test equals com B, the length of train all the way to the end. And we're going to split the data set into training and validation sets using sklearn's train test split to do that. And you can see now we've got 146 columns of data. That is a change from, I think, 171. So I think that's 25. We were able to reduce it by 25 columns. Now we define our model. We use MLP classifier. We have hidden layer sizes of 200, max iter of 5,000, random state of 42, early stopping equals true, and we're going to fit X train, Y train, and then you had an accuracy of 94%. We're going to predict on the validation set, and when we predict on the validation set, we also have an accuracy of 94%. We put it on the confusion matrix, so the confusion matrix tells you how many you got right and how many you got wrong. Now we're going to predict on the test set, and you're going to get a bunch of zeros and 1. I put the predictions on created a histogram with sklearn, so you can see that the histogram looks very similar to the histogram of the target that we previously created. So that's telling me that maybe we're on the right path. We checked our unique values, and the ones were about 10% of the zeros. And then we prepare our submission. The predictions equal submission churn probability, submission.toCSV, submission.CSV index equals false, submission equals pd.readCSV, submission, and then submission. So we've got our submission. And then what I did was I saved it. And then when I saved it, I submitted it to Kaggle, and I got a 93.886%. But I think what I'm going to do is I'm going to drop the ID because I don't need the ID, and that might improve my score. You never know. So I'm going to leave you to it. I hope you liked this. I showed you everything that I did to make predictions on this data set, and my predictions weren't that bad. So if you like my video, please like, subscribe, and share. If you want to be notified whenever I'm making a new video, please tick onto the bell button next to the subscribe button. And thank you so much for watching my code review. I look forward to making more code reviews for you in the future.